So hi everyone, I'm Steve and I've come from China. So I've come a ways to talk to you. And this is what we do there. This may not look overly Chinese to you, and it's not. But I figured since we're in Nashville and we're the center of country music, this somehow applies. And as you'll see, given what we do, this is pretty much applicable also because this is how I feel a lot. So what do we actually do way over there? So we're actually a managed service provider. So to give you some context on what we do, we're been there about 10 years, and our job is to build, take over, and run big, messy systems in China, and where things change a lot, and so on. So we've been, a cloud provider, and we work on a dozen clouds or so, probably 50 or 100 data centers, sort of all over Asia, and so on. So lots of nitty-gritty, hands in the dirt kind of things going on. So lots of fun. So a quick word about China. It's far away. It's a pretty big place. The internet there has 800 million users. And at Chinese New Year, when we all pay each other, sort of red envelopes, it's about 1 million transactions a second, clearing, paying off all your employees and friends and so on. So stuff is fairly sizable at scale, but given similar scales, North America and Europe and stuff. So it's also things change a lot. Things usually aren't planned as well as you might like. And it's kind of a chaotic, messy place in a lot of ways. So that's the fun of all this. So we think of systems in a few different ways and dimensions. Let's give you some context. You can have new systems, of course. Those are very nice. I'm sure you all have new, shiny systems. There's also old systems or existing systems. We also think about, what's the size, right? To us, small is about 1 million users. Large, maybe 10, 50, 100 million. Our biggest is probably 250, 300 million users on a daily or weekly basis. So, reasonable size. Some are modern, some not so much. We have, I'd say, the most of our customers still FTP, most of their code, most of their stuff, still just getting into more modern DevOps. I'm sure you're all way more modern than this. And some systems are clean, organized, documented, super nice, some not so much. So our life is over here, as you might imagine. So that's part of the color of the whole talk. So how and why do we do this? Reality is anybody can build a new system. We can use Terraform, we can do nice, new, shiny stuff, and we do that a lot, but that isn't really fun. The real challenge is taking things over, right? Where you're trying to, as you're running around the bullpen or whatever, trying to take over and manage and fix up this other crazy, wild thing, all while it's in motion, because we have to do all of our stuff basically without downtime, without significant downtime. So, it's more difficult, we think. Now, we'd love to just rebuild it. Right, that'd be the easy thing, and sometimes customers let us do this. Just take that old thing, move it to AWS, move it to AliCloud, rebuild it from scratch, and that's really nice, and I'm sure you all get to do that all the time. We have to play the ball where it lies. And so, I feel like this a lot. The customer says, this is what we got, and they're going to pay you, and that's what you get, right? And we also do full stack, full everything, so we really can't say, well, we don't support that. We can say we don't support it that well, but we have to deal with it, right? So you get all kinds of custom stuff. So this is my life. Usually when we get it, the patient's bleeding, and I'll talk more about patients in a while, but usually something's wrong, right? That's why people come to us. They've got security problems, downtime, lots of issues. So we think like an ER a lot. There usually are bodies buried all over. You might know this as technical debt, but it's actually sometimes worse than that. And our job is to do all that and basically rebuild the race car during the race, right? So we do a lot of sort of rebuilding systems while they're running. So obviously it's just pieces and parts, and I'll talk about how we do that a bit. So we kind of have 4 phases. So first one obviously is stop the bleeding. Places like China, people are not real patient with our patients. So what happens is they often say, well, it's been a week. Why haven't you fixed everything already? And we don't want to anymore, kind of problem. And so we very quickly try to fix immediate bleeding because that makes the customer feel good, makes them worth like paying us money, and sets the stage for going further. So that's the main thing. So it's very much like an ER, right? Find the bleeders, sew them up a little bit, put some Band-Aids on, stuff like that. So it's talking to stakeholders, figuring out what matters, figuring out the people who write the checks, what they care about. Things like that, getting some monitoring, surveying kind of what you got. Sometimes literally customers have no idea how many servers they have. They don't know where they are, what data centers they're in, things like this. Right? So this is kind of what we run into. Backups. I've yet to find a customer that has RAID monitoring, so we walk around and look at the lights and stuff. Literally, RAID monitoring in most cases, a guy walks around the IDC data center looking for red lights. That's 90% of our customer base. So that's fun. You see some other problems here. People are all gone, usual kind of takeover stuff. And I imagine many of you're going to run into this if you do takeovers or M&A or kind of take over a new department, kind of like this. So what do we use for tools and how do we think about this? And I'll go through these in a bit of detail here, what we use. The first thing is we have to get monitoring installed, and I know because a lot of you are at the leading edge of observability, I'm sure, and beautiful DevOps monitoring. We struggle to get the basics. I have a customer I talked to, or a potential customer a couple weeks ago. Their monitoring on their sort of multi-hundred server thing is a cron job that runs every few minutes. If the CPU is high, sends them an email. So we can improve on that. And so we try to get monitoring installed, but it's really important because you're trying to roll this out in a fairly large fleet of systems you don't know very well. And so you can't just either tell a customer to do some yum installs. Most cases, they don't have Puppet or Chef or Ansible or whatever. And so, first rule of this is don't kill the patient and don't cause downtime, which we do, unfortunately, sometimes. So we really try to use Ansible and so on to get things out there. And it's not just installing monitoring. We use Zabbix in most cases. It's not just installing it, but you have to reconfigure the services to support it. So Apache Nginx, you have to turn on the service paths. MySQL, you have to add users. Tomcat, you have to turn on JMX. We have to do all of these things that are more than just installing the monitoring system. And we have to figure out how to do that automatically, or we can't sort of do it at scale. So we do a lot of that, adding logs, this kind of stuff, reconfigure, restarts, all that. So Golden Signals are great for us. You read about these, of course, in the sort of Google book and so on. And I've written about sort of how to get them because they're great to talk about. And Brandon and people talk about them, and they're super useful. Not that many people talk about how to get them. And these are actually pretty hard to get, particularly from logs, from Apache, from load balancers, things like this. So I've written about that. We have a bunch of custom tooling that does this for us because when you have a lot of microservices, a lot of crazy stuff you've never seen before, who's talking to who and where's the latency and where are the problems, that kind of thing. We get a lot of cases where Java is misconfigured, where they didn't specify a maximum heap. So you've got a 16 gig machine using 1 meg of heap. And of course, under load, it immediately falls apart. And you have microservices and you have 20 of these. And so where's the problem? This really helps us kind of figure that out. We also are huge believers in CMDBs. However, to us, the sort of generic CMDB of my assets and what software installed is not how we think about this. We think about deep inspection. So we read and parse and build a model out of every configuration file of everything. Right? All your startup scripts, what's running, all your kernel settings, Nginx configs, MySQL, Java, everything. Because we want to know what SSL versions you're running, what vhosts you have, where the logs are, MySQL configuration 100 different ways. We really want to look at this stuff. We want to differ it across different hosts because you'll have 50 web servers. 4 of them don't work well. Why? So we have to figure this stuff out. So we have lots of tools for this, which then leads us to be able to audit systems. So we take all the config systems and we run it through rule engines. We have 500 or 1,000 sort of rules. And they tell us, okay, MySQL has this bad habit, or you didn't configure JMX or XMX or whatever. So this really helps us quickly figure out where the most egregious problems are. And there's lots of them. MySQL InnoDB buffer not set, therefore it's using 8 megabytes of RAM, stuff like this. So this is super useful to us, and a few examples there. We also do this in the cloud. So similar to things like Evident IO and some of the Trusted Advisor, we have this for a bunch of clouds, where we can also tell, open security groups, all kinds of other bad habits you might have in the cloud, wrong size disks and so on. This again helps us find real problems. And at the end of this phase, our job is just really update the configs, fix the critical stuff, get the patient to stop bleeding. So then we can get some more time. So we try to do all of this in a week or so. Next phase is find the bodies. And this is really to help us plan, where we're going to go for the next, month or two. And so we need a shovel like this and digging. And also without breaking the system. You'd be surprised how many things you can break by just looking around. And we find lots of things. Usually if you talk to the CEO, CTO, kind of senior folks, they think they've spent lots of money to buy a nice shiny truck like this. We often find looks more like that. And there's a whole bunch of stuff. In China especially, it's great to run lots of services on one server, one VM, 5, 10, 20 things, all interconnected. People love to run lots and lots of Tomcats. I've yet to see anybody who runs multiple apps in a Tomcat. It's let's have 10 Tomcats running on, a ton of different ports, all kinds of memory. try monitoring this. 4 or 5 MySQLs on one VM, completely different MySQL instances. That's fun. Very few updates. We recently had a customer that was running Red Hat Linux 6. This is not Red Hat Enterprise Linux 6. This is Red Hat Linux 6. Near as we can tell, it's about 22 years old, maybe 18 years old, I forget. And they have 7, 8, 9, Red Hat 1, 2, 3, and so on. And they have dozens of these, right? So how do you even install monitoring on that? I don't know yet. So anyway, amazed what you find. This is one of my favorites. This is an early customer. VM, you got 3 Apaches installed on this. One yum package, RPM. One's a tar file and one's from source, right? 2 of them are running. And which one do you think actually proxies the whole darn site? It's the one started in somebody's home directory 2 years ago. And so you try to start, what service scripts run what, and this was anyway. This is the kind of stuff we run into all the time. And so, it's interesting. Microservices, probably some of you see this. People starting to do this, of course, right? And more the better, right? And so we have a customer that just redid this, and there's about 30 different services. And they're nice. They're all in HA pairs. You have payment 1, payment 2, customer 1, customer 2, and so on, except they don't actually do the same thing. And some of them aren't even running. And this melts down at 3 in the morning. How do you figure out what's where? I had that fun about a month ago. So a very confusing mess. And so we try to, dig through this. But and this is all, this place has, I don't know, 25,000 retail locations tied to it, something like this. So how do we do this, right? Here's some tools that we think about. So one of the things we do is link dependency or links and dependencies. We're trying to build not only configuration structures or how is everything configured, that's great, but how is it all connected? So we have a bunch of tools that run out and run netstat, SS, and so on, trying to figure out who's talking to everybody on a network level. This is connecting to that, especially with microservices, who talks to who and so on, and we build kind of pretty charts like this. So we could begin to see who's talking to who, especially as systems get larger. You have dozens of systems and services. Oh, I didn't know this thing talked to Elasticsearch, and I didn't know that thing used Memcache, and that kind of thing. And sometimes the customer doesn't know either. So especially you get large systems built by third parties or maintained partially by third parties, and everybody's changing stuff. So it's interesting. Also, deeply monitoring. So everybody has monitoring. We tend to think of monitoring very deeply, so we tend to monitor hundreds of things across complicated hosts per server, especially in large-scale stuff. Things like the kernel's gotten better certainly, but things like contract, things like slab size, things like buffers really matter when you're serving 25,000 ads a second, or carrying 1 million connections on a Linux box. So you've got to really monitor a lot of different things for lots of different services. So we have sort of deep best practice for lots of stuff. This obviously gives you your golden signals, logs, and so on. So we really try to look at this, not so much for alerting, but particularly, again, for auditing and finding what's wrong. When things go bad, how do you dive into MySQL, dive into Java, that kind of stuff. So all interesting. Obviously, logs, a lot of our customers are not, and I think even the US still, are not always as log-oriented as they ought to be, or logs are pretty much grepping log files, on the server. So we centralize all this, run it through Elasticsearch and so on, and pull metrics out, pull analysis out, so we can, we have online tools to give us, top URLs, top IPs, top paths, MySQL slow logs, top SQL, all this kind of stuff. Again, to help dig into what's going on these servers and where the problems lie. Hunting 500 errors is one of our favorite pastimes. Or hunting abnormal 500 errors. There's usually lots of them, and you can't figure out which ones matter. But that's another problem. But this is just really important, obviously, to helping the customer get up to some basic standard of operational stability as they scale. A lot of customers will start small and then launch, and all of a sudden it's 20 million users, in a day, and this kind of thing. Some stuff is not so sexy, but backups, especially not on the cloud. And we have unusual problems because we have systems that change a lot. And so I've seen this several times where, you have backups running, MySQL's running, it's great. You have maybe Magento. It's your Magento database, right? And this is running your e-commerce site, and it's all happy. Except 2 years ago, that was upgraded, and now there's a database called Magento New. And that's the production database, but nobody updated the backups. So we're backing up the Magento database just beautifully every single day, except that's not what anybody's using. And so we have tools to go hunt this stuff down and compare backup, configuration scripts with what's actually running, which file systems are mounted, which databases are running, and you have to have exceptions, and you have to have a manual approval if you don't back up one of these things. And we just try to keep all this herded together because we have on occasion not had backups ready when we needed them. And this is why. So it's not very sexy, but very important. Same thing, we have a file digger. Customers are FTPing files, but even Jenkins makes these mistakes, right? You're in PHP, you're in Python, other things, where you've got frameworks now that aren't just code, because inside the framework directories, you're writing caches, you're compiling JavaScript, all this kind of stuff. So half the directories are read-write. Half the directories should be read-only, what the code is. And this is forever getting mixed up, and customers love to do 777, right? We've had more than one Tomcat server broken into because of this kind of thing, and PHP and so on. So we have a little digger that goes through it. It knows about Magento. It knows about, we don't see much WordPress anymore, but it knows all the versions of all these things, and it digs in them and knows that directory should be read-write. This one should be read-only. This should be this. This should be owned by these users. This should be owned by Apache because it's running this, and just fixes all that. It's a real pain, but it's just really important to maintaining real security for your customers because it's so easy to get lost here, right? And of course, with all the recent exploits, especially in Java and various things, and then kernel problems, it's very easy to take over your whole world this way. So that's the end of phase 2. And sort of discovering out of this, we sort of have a plan. We figured out where the bodies are. We figured out kind of what has to be fixed, what the customer can afford, kind of what we deal with that, right? And so now our job is to rebuild the Racecar very much like a pit crew while it's running. Now, sometimes we get the little pit thing where we can stop for a few hours, but usually we have to do it out while it's going around the track. And so it's really, basically upgrading in production. So this has been deployed, and we're up here kind of doing this. And I'd like to tell you there's a million awesome tools to do this, but it's really about project management and customer management, and particularly how do we do this not at 3 in the morning, because every customer wants to do this at 3 in the morning. My team doesn't love working at 3 in the morning. And so you can do it once or twice, but when you have dozens of customers and they all want to do it this way, you have a huge work life and many other sort of problems, plus making mistakes. So we really try hard to sequence all this and build stuff in a way that we don't have to do that. And obviously our goal is not perfection, it's just to make it better. So many times we'll go through several phases of this, trying to improve as we go, because as you know, perfection is the enemy of making it work. It also creates downtime and it's expensive. So some tools we have for this and ways we think about this, a bunch of stuff. One is just best practice configs. We have spent a lot of energy over many years, and I should open source this more. I need to get these out there. Building the best practice configs for everything, whether it's kernel stuff, Nginx stuff, MySQL especially, Cisco switches, RAID cards, and all this. I would put our configs up against anybody in the world in terms of reliability, security, best practices, and we really need to share that more. But this saves us a lot of problems because just engineering things properly and correctly just makes it so much easier later, and we avoid a lot of typical problems I think you run into. And this is what really worries me with sort of more DevOps. Developers taking configs kind of generically, changing a few things, throwing them into Jenkins, push them out. The quality of those configs, they're great, they're immutable, they're published out every day. It's not always so great because they're really not thinking about security and all the different best practices of every little aspect of everything. SSL, keys and all this kind of stuff is not as optimum. We really spend a lot of time on this, especially in networking. Automation, is part of our tool to do this, but again, we're supporting a hugely diverse set of customers across hugely diverse fleets, so it's not as homogeneous at all. So Ansible is our friend. Puppet and Chef and so on really aren't very useful to us because they require central services and agents, and they're actually very dangerous in our opinion because if you make a mistake, they wipe stuff out. Ansible is a lot more useful. It's SSH, it's understood, customers have it, and so we try to, as we go, automate things, upgrade things. Hard to be generic doing this. One of our biggest friends is actually load balancers. Often, customer doesn't always have them, or they're using Nginx or something that's not that configurable. So we tend to go to HA proxy or web stuff or cloud stuff. But super useful because now if I have obviously 2 web servers or 2 whatever servers, I can take one down and I can upgrade it. Or sometimes I'll add in the middle, add a new one, add the old one. I can do canary test and I can do all kinds of stuff. So it's an underappreciated technology, I think. Obviously for load balancing and reliability, but just for being able to do upgrades, rolling upgrades, configuration management during the day and during production. Because without this, what are you going to do? Right? You have to take stuff down. Right? It's not so useful on databases, but more useful across all kinds of other things. So we're huge HA proxy fans, although it could be more dynamically configurable and a bunch of stuff. So we've got some stuff we're still working on We're trying to find ways to auto-fix stuff. So if the audit finds your MySQL is not configured very well, how do we automatically fix that without breaking the system? How do we do it safely? Been working on this for a while. And also trying to model the whole system. Some of our tools now can build sort of entire stacks of how all the VMs are built, how all the systems are built. We think of AWS config, but for the OS and all the services on top, we're sort of building those sort of models for all that. So that's very useful. Here's just some examples of some of the stuff we've done just internally of some of the big giant Magento systems, game systems, migrations, consumer stuff. Again, some of these are up to a few hundred million users a day. Most of them are smaller. And then, we're done with this. Great. Now we're in phase 4. Now it's smooth sailing, right? Everything's beautiful. We fixed everything. Everything's perfect. The customer's been roped and all that. So, it's all nice, right? And our goal in operations, because we're really an MSP, 24/7 operations, my goal is that any engineer on call any night can deal with any problem at any customer at any time, even if they'd never heard of it. We're not always there, but that's our goal, and that's a pretty tall order. But that's how we think about things, and fix it in 15 minutes. This takes a lot of documentation, a lot of wikis, a lot of procedures. So our alert system links to automatic procedures that are either generic, global, tied to the customer, tied to the server, tied to the service. We have automatic routing of a whole bunch of this stuff. We have expert systems to help you troubleshoot. We have a whole bunch of things to help you sort of figure this out. Pre-production checks are super important. So we run full audits before we go to production if we can, especially for new systems. And that's really extensive to make sure we don't have problems later. And I think people don't do this enough. They kind of have something simple. We really do an extensive audit because not everything always gets done. And it blows up a month later or a week later and you look really stupid in front of customers. So we do that, and we try to familiarize our teams. We do walkthroughs with the ops teams and so on. So important. And reality is it's still chaotic. Customers still change stuff all the time. One of our biggest customers, entire rack of servers would just disappear out of our monitoring system and get alerts, right? You call a customer, oh yeah, we just took that offline. We disabled that feature, and without telling us, right? And so this used to happen every day. So kind of a problem. So we have to watch them like a hawk. So we have lots of tools that actually, again, CMDB, we actually have SSH command line captures. So we have command logs to know what you did. Especially if you reconfigured stuff, we can see the configurations. A lot of people say, oh, I didn't change anything. We didn't do any deploys. We didn't do anything. And we need evidence. And so we believe the servers, and we don't always believe the customer. I don't have details on these tools, but we have some auto-healing stuff and root cause analysis and incident management, a bunch of stuff for this because this just really helps us keep the cost down and the customer up and happy. So finally, some lessons learned. At least for us, the world's not always perfect, and I think in these days of everything's DevOps, everything's infrastructure as service, everything's immutable, everything's perfect, which is I'm sure how all of you have your systems. It's not always like that, especially in our world. And it's just messier. And for us, the source of truth is always what's running. We hope that matches what we think it does, but we really have to go check. I think the world could use more of that because it's not always perfect. Document everything, that kind of stuff. So this is all really important. Some takeaways is that DevOps and cloud native not important. Document secure, and the bottom one is trust but verify. That's what we do.
David Lynn, Vanderbilt University. So about 15 slides back, you talk about replacing configs of pretty much everything with best practices and such. How do you deal with the things that work only because of a combination of misconfigurations, not a single misconfiguration, but a whole chain of them?
Yeah, that's a real challenge. Often stuff is relatively simple that even though it's large, we don't have many folks that are really, really complicated, and things like Kafka and huge event streams, and we have some Hadoop stuff and so on. Usually fairly simple. So only it's 1 or 2 levels typically. And the CDNs will be very simple. So usually it's just debugging some of that. But there's sometimes we had a hybrid system like that. It took several senior engineers 1 or 2 months of just playing around in production to get the CDN to work correctly, because it was just all these different levels. That was a new system. I don't know how you would ever do that in design or test or whatever, because it was a global system, and it happens, but you change little things one at a time. Some of it's also just deeply understanding how things work. I mean, you really got to understand HTTP and forwarding and proxies and networks and all that, and we can debug pretty quickly. SSL causes its own problems, SNI, all this kind of stuff, but it's as you go. There's no magic, I think.
Hi, Emily Gladstone Cole. I love this talk. It's a messy part of everybody's job is coming in and having to pick up an unknown number of pieces that are in an unknown number of places. Is there anything that's not, super private that you can tell us about the CMDB and the processes that you go through to gather all that data other than just getting Ansible installed everywhere?
Yeah, so we have the CMDB and the audit system actually run on a collector. So we actually have a collector, it's Python right now, and it runs every day and sometimes every hour on every host everywhere. And it's modular, and so it's 50 modules or something. But it really just gradually captures everything. It generates a giant JSON file, which then it tars up and sends to a backend. And the backend actually explodes that into just so that you can parse. And then we have rule-based rules that run on that. So if you shouldn't have this kernel, that it runs on all that. So it's pretty basic, but it runs on thousands of hosts.
It sounds super useful. Have you considered making it open source?
Somewhat. A bunch of this is actually part of a product that we're going to be bringing to the U.S.
Ooh,
and going
okay.
to be some of that. So that's what the thing at the bottom is.
All right.
But
I'll go check that out.
But also we might share some of that also,
Yeah.
some of the other pieces, and try to spin off some of the tools and pieces.
Super.
And also we're super happy to talk about how stuff works
Uh-huh.
and how we did it and share the code, a lot of stuff.
Thanks a lot.
Hi, most of what you've spoken about has to do with the data center, especially from a standpoint of SLAs. How do you isolate yourself from the network, the desktop, the POS, those types of things?
Well, most of our stuff is internet oriented, so
Okay.
it's not enterprise, if that's what you mean. Or just the
So
network
somebody's
design.
getting data into your data center. I'm sure that the ISP providers, the network providers and whatnot in China must have their own glitches. And then, okay.
So I have a whole separate talk actually that I gave a few years ago at a similar event on the fun of the Chinese networking. We didn't have BGP available. Still don't in many ways across a lot of data centers. You had to buy links from each carrier at one point in time and just separate IPs. So you'd have 3 or 4 public IPs for every service. That's mostly gone away now, but that's fun. And that's just a big issue, right? CDNs, people are pretty tolerant. The networks have gotten so much massively better. Everybody's got 4G everywhere, including subways and elevators and everything. Actually, it's way better than here, really. I'd say networks are pretty good. We don't deal with it a lot. Some end user APM tools, stuff like that, but nothing. CDN is not as popular as it should be, also for day-to-day stuff.
Okay, thank you.
Yeah, no.
Okay, we've got time for maybe one more quick question.
Nailed it. Awesome. Paul Riley, One Neck IT Solutions. My question is, I'm actually in a similar space working for an MSP. What's the breakdown between, I'd say, the human Turk and automation? Because I know Ansible's got some limitations regarding, like, specifically older than, I think it's EL4 and older systems can't talk to it.
Yeah, well, we've mostly now got on everything sort of CentOS 6 and above.
Okay.
We run almost everything on CentOS. We don't see a lot of Ubuntu, and we actively discourage it, actually, which we can talk about separately. But
so
that's what you mean. So our targets are not too diverse in that sense. They're diverse in many other things, but not in the OS.
So with your customers, do you then push them in that direction prior to doing that, or
Yeah.
okay?
Yeah, hard.
And then you fix it after the fact. Got it.
All right, let's have one more round of applause for Steve.